Firewall and port forwarding with a DIVUS heartbeat. Today we talk about advanced settings that can be made on the heartbeat to optimally manage the network structure. Before we look at how to create rules, we see how a DIVUS heartbeat is networked. We have three networks. The network for our home automation devices is called DIVUS Secure Intranet, or DSI for short. The network for external devices and intercoms, which are intended to communicate through intercom with our home automation devices, is called Residential Intercom Network, or RIN. In an island system, these two networks will be all there is. If you wish to have a communication with the household appliances, the Wi-Fi, and probably also the internet, then there will be a third network, which we call home LAN. The special feature of the DSI is that the devices that are associated with it are considered trustworthy. In practical terms, this means that, for example, a touch zone from there can reach all other devices. So, it can easily communicate with a KNX server, which is in the same network. It may as well retrieve the image of an IP cam in the RSI, or control a Sonos system that runs in the home LAN. Attention, it's about the direction of the query. From DSI to the outside, yes. But how does it look the other way around? There is a firewall around the RIN that does not permit external communication. The only exception is the port for VoIP. So, from RIN to DSI, no. Elsewhere, neither. The ringing at the external station and then the voice communication reach the device inside the house only because the VoIP server establishes this communication. Nothing can go directly from the RIN to the outside. For home LAN, there are also a few special features that are interesting. The first one is that home LAN and DSI are in the same network. This means that an internet router, which operates internally as a DHCP server, will distribute its addresses to mobile phones, laptops, as well as to DIVUS touch zones or DIVUS superiors. Devices in the same network can always establish a direct connection, without having to run through the gateway. So, how can you manage this dangerous mixture so that the security, bandwidth, and reliability of our system are still guaranteed? If we take a closer look, we see that the devices have only the IP addresses in common. Firstly, our home automation devices are connected to a separate device, namely the managed switch of the DIVUS heartbeat. This means that the bandwidth depends only on the traffic over the switch, not on, for example, the streaming or downloading of a device in the home LAN. Second, there is a firewall that makes the separation even clearer. From home LAN to DSI, no. Every communication in this direction is blocked by default, and this communication direction includes any attempts that could come from the internet. So, this is our starting point, a sophisticated system with a clear separation of function and security risk, which easily allows all the usual communications without sacrificing strict security measures. I want to explain one last thing to you before we finally get to the rules. A DIVUS KNX server or KNX superior is detected by the heartbeat during the scan. In this particular case, some rules are automatically created. 2 port forwardings over port 3000 and 3001 for the first such device, and possibly consecutively 3002 and 3003 for a second one. These are used to reach the device regardless of its IP address, namely the host name of the heartbeat. This is explained in detail in another tutorial. In addition, 2 ports of the KNX server or KNX superior are released for access from the home LAN, port 80 and port 443. So, if you want to control your home automation via smartphone or tablet with the Optima app, you can also address the KNX server directly. Whether so or via the hostname, if you need remote access to Optima, you must specify a forwarding on your internet router that either directly addresses the KNX server or the heartbeat on one of the above mentioned ports. The best thing to do at this time is to ensure that the device you use in the rule is always assigned the same IP address. This one-time procedure is to be carried out whenever a new internet router is installed, which should allow access from the outside to Optima or another service. As you can see, we did not need a firewall rule or port forwarding on the heartbeat yet. Everything happens automatically. It may be necessary to add a firewall or port forwarding rule only if you have special devices or special needs. So let's see how. Under Settings, we go to Firewall Rules. There, if available, we will find the list of existing rules. Through the button Add Rule, we get to the form, which allows the configuration of a firewall rule. Here we will fill in only the fields where we need to have a special value. Values left empty will be interpreted as any value of that property being acceptable for the current rule. Attention! Define your rules as specific as possible. Too generic rules can jeopardize the security of the system. Under Firewall Rule Type, we find all 6 possible directions. Keep in mind that the rule can not only open, but also explicitly close or block a communication channel. An IP address is entered here as normal. For example, like this. If it should be a range or an entire network, the indication looks like this. /24 corresponds to the classic 255.255.255.0 mask because there are 24 bits that are corresponding to the network part of the IP address. If your mask is different, adjust the number of bits here. Everything else should be self-explaining. After saving, the rule is immediately active and will be displayed in the table. If there are multiple rules, you can change the order. They are implemented in order from top to bottom. If there are overlaps, the first matching rule is applied. You can activate or deactivate an existing rule directly from the table, edit it, move it up or down, and of course you can also delete it. Now, let's look at the port forwarding rules. As mentioned before, such a rule is preferable if you want to use the IP-independent addressing of the heartbeat, which uses the hostname of the heartbeat. You can then address services offered elsewhere by accessing these devices over the heartbeat through specially assigned ports, which will take over the forwarding to the target device, through a so-called port forwarding rule. The details of such a rule include at least an input port, that would be the port of the heartbeat on which requests should be listened to, a destination IP address, and an output port, a port of the target device to which the traffic is passed on. A description serves to recognize the rules more quickly, but is not absolutely necessary. That's it. Check it out and have fun.
DIVUS.